Hello. Now, today we are going to be starting inferential statistics. And what does an inference mean? In this case, for maths anyway, it's going to mean that we have a small amount of information and we're going to try and make an inference about a larger population based on this smaller sample that we've got, this smaller piece of information that we've got. So we start out with something called proportions. So I've been trying to think of the best way to introduce this to you, and I think doing an example is probably the best way to jump into it, and we'll talk about what's going on as we do it. So we're going to have a look at question 12 on page 322. Now, if any of you have been reading ahead and know the theory behind this, I'm glossing over where the argument for this is coming from. In the exam papers, you haven't been required to know it, so I don't particularly want to take up your time with explaining the subtleties of the argument that this is actually based on. I'm going to give you the information I believe you need for doing your exam questions, and if any of you want me to make a separate video explaining why this works, I'll absolutely do it, but I don't want to take up your time with it because I don't believe we need it for the exam. So let's have a look at question 12 on page 322. An importer has ordered a large consignment of tomatoes. When it arrives, he examines a randomly chosen sample of 50 boxes and finds that 12 contain at least one bad tomato. Assuming that these boxes may be regarded as being a random sample from the boxes in the consignment, obtain an approximate 95% confidence interval for the proportion of boxes containing at least one bad tomato, giving your confidence limits correct to 3 decimal places. Now, that's a bit of a mouthful, but what we've got is a story of a person getting a whole load of boxes that have tomatoes in them, and he doesn't want to have to test every single box to see if there are some rotten tomatoes in it. So instead of testing every single box, he's going to the importer is going to take a sample of 50 boxes. And he's going to base his judgment on how many boxes in total have rotten tomatoes in them, based on this sample he's taken of 50. So he takes 50 boxes, and based on what he sees in those 50 boxes, he's going to decide what's happening with all of the boxes that he's got. So he's making an inference. He's using these 50 boxes, and from those 50 boxes, he's going to make an inference about the rest of the boxes that he's imported. That's where inferential statistics come from. We're going to make an inference based on our sample. Now, our sample size is 50. We take 50 boxes, so we say n is our sample size, and it's going to be 50. That's our sample size. And our sample proportion, that is the proportion of our boxes that have rotten tomatoes in them, at least one rotten tomato, we call p hat. So P with a little chevron on top of it, a little arrow on top of it, is our sample proportion, and it's going to be the fraction of boxes that had at least one rotten tomato. So we had 12 boxes with rotten tomatoes in them out of a total of 50 boxes. And we'll basically always write our sample proportion as a decimal at 0.24, and that's our sample proportion. So far, hopefully so good. We've got a particular sized sample that we've taken, and we've got a particular fraction of our sample that has rotten tomatoes in it, and that's our sample proportion. Now, what we're interested in is using this information to figure out how many boxes in total, or rather the proportion of boxes in total that is going to have rotten tomatoes in it. That's our aim. So what we're looking for is called P, which is the population proportion. So P hat was our sample proportion, and P just by itself is the population proportion. So the population proportion is the fraction of, or the percentage of, boxes in total that have Rotten Tomatoes in them. That's what we want to know. So based on our sample, let's see what we can infer about the population, about all of the boxes that we've got. Now, in Leaving Cert Maths, you're only required to know about one confidence interval for this type of question, and it's called the 95% confidence interval. Now, when I say 95%, hopefully that rings a bell with you. That was one of our pieces from our empirical rule. If you remember, we have our random variables that form our normal curve, and we would have our middle piece here. Now, up until now, this has been the mean. Right now, this is going to be our sample proportion. And plus or minus what away from our middle position is 95% of our population. Well, in our empirical rule, it was the middle minus 2 standard deviations, and the middle plus 2 standard deviations. And that was 95% of our population, if you remember back to our empirical rule. And we know that probabilities are also can also be modeled using our normal curve. Now, we learned about the empirical rule only being very approximate, so the actual plus or minus of our standard deviation for 95% of our curve is the middle plus 1.96 standard deviations and the middle minus 1.96 standard deviations. So how does this actually work out? We have currently got a particular proportion of our boxes that have Rotten Tomatoes in them. Now, based on that, we're able to give a range of possible proportions that we are 95% confident the true population proportion is within. Now, if that makes sense to you, perfect. Hopefully by the end of the question it will. What we need to do is find a range of values, range of possible values for the population proportion based on our sample proportion. And the way that we do that is we're going to take our sample proportion minus 1.96 times our standard deviation up to plus 1.96 times our standard deviation. This is effectively the plus or minus 2 standard deviations away from our mean that we talked about when we were talking about the empirical rule. Now, that is most of what we need, but if we look here, we don't have any real idea as to what the standard deviation is. Well, there's a formula for that, and it's on page 34 in your log tables. I should actually have a little p written in here. That would be very important because you have to deal with another standard deviation in another type of these questions. So, to find our standard deviation, which for reasons I'm not too clear on, they decided to call the standard error in population proportion questions, we have, it is going to be square root of p hat on 1 minus p hat all over n. This formula doesn't need to be known by heart. It's on the bottom of page 34 in your log tables. So whenever you're doing a statistics type question, you're going to open up page 34 in your log tables, and 34 up to, I think, 37 has all of the formulas you need. Now, let's find our standard error for our particular problem. Well, we've already written out the information we need here. We know that p hat is 0.24 and n is 50. We sub that all in. 0.24, 1 minus 0.24, all over 50, and we get 0.0604. Keep the rest of the decimals in your log table. We want plus or minus 1.96 times this, and we call that the margin of error. So we have plus or minus 1.96 times our sigma p gives us 0.11838. Now, we are 95% confident. Well, I'll write it out first. 95% confident. Beautiful. P hat minus 1.96 sigma p. P hat plus 1.96 sigma p. If we sub in this, we have 0.24 minus 0.11838, 0.24 plus 0.11838. We put that in and we get 0.1216 p 0.3584. Now, I'm going to turn this into, that is, you'd round that to 3 decimal places for your final answer in this question, but I want to talk about what this means. So, turning that into percentages. Would look like this. Now, based on our sample of 50 boxes, we are 95% sure, 95% certain that between 12% and about 36% of our boxes, of our total boxes, have spoiled tomatoes in them, have rotten tomatoes in them. That's what our 95% confidence interval gives us. We are 95% confident that somewhere between 12 and 36% of our boxes contain rotten tomatoes, at least one rotten tomato. That's what our 95% confidence interval is giving us. And these questions, while being a little bit messy to remember all of the steps, and unfortunately more steps are coming for an exam style question, they are very, very predictable. Because there are so many steps you have to remember, they're fairly straightforward in terms of their implementation in the exam, and their meaning is also quite consistent. For an exam style question, you will be explaining briefly what it is that your answer means. So that's why I'm lingering on it here. Between 12% and 36% of your total boxes of tomatoes have at least one rotten tomato in them, and we are 95% confident of that, and the 95% comes from this plus or minus 1.96 times the standard deviation. And that's what we need for right now. On Monday we will be talking more about applying this again, so don't panic if it hasn't totally clicked with you yet.